Thanks for joining me in today's lesson. In this first tutorial, we will rationalize monomial denominators. So we continue in chapter 6 and we're looking at 6.3. We're going to look at a method called rationalizing the denominator. There are two more rules for us to have a simplified radical. Rule number 1, you may not have a radical in the denominator. Rule number 2, you may not have a fraction or a decimal as a radicand. So that means anything underneath the radical sign, it cannot be a fraction, it cannot be a decimal. And so far, this has not really been a concern for us. If we've seen a problem like this, which is clearly breaking rule number 1, we cannot have a radical in the denominator, and there it is. That's okay, because we know that if we have two square roots that are being divided, we can put them both together and make one giant fraction with the square root symbol. Which now, of course, is breaking rule number 2 because we cannot have fractions as a radicand, but that's okay because 20 divided by 2 reduces to 10, so we just have the square root of 10. And this is not breaking any of the rules, so that's fine. Number 2, same situation. We've got cube roots this time that we're dividing. We can put these both together as 16 halves, one giant fraction. And I know that's breaking rule number 2, but that's okay because 16 divided by 2 becomes 8. So this is not breaking either of these two rules, but it is breaking our main rule. We cannot have a perfect cube still in a cube root. The cube root of 8 is one of those numbers that we remember is 2. So our main rule is we can't have any perfect squares or cubes or fourths or fifths underneath that same root. So that has to simplify to a 2. And our third one, same situation. This time we're dealing with fourth roots, and we can make one giant fraction. That's okay because 81 divided by 3 becomes a 27. So now we don't have any radicals in the denominator. We don't have any fractions as a radicand. Let's see if it's breaking any other rules. I might need to look at my powers table, but I'm pretty sure 27 is not a perfect fourth. And in fact, there are no factors of 27 that are perfect fourths. So this must be as simplified as I can get. It's not breaking any rules. So far, this has not been a concern. We've been able to handle these two rules by doing some simple math because the fractions reduced. What happens when the fractions do not reduce? If we have the square root of 10 divided by the square root of 3, well, sure, we can go ahead and try to put that as one big fraction, but that's not really going to help us at all. 10 thirds does not reduce. This first problem is breaking rule number 1 because of the radical in the denominator. The second version is breaking rule number 2 because we can't have fractions. So neither of these are very helpful. What we're going to do is called rationalizing. We need to ultimately clean up this denominator and make sure that the radical symbol is no longer there. Now, understand that this is just a number. We could plug this into the calculator and get an approximation for what this number is, but it is ultimately just a number. This is not an equation. The only thing I can multiply to this number without changing it is 1. If I multiply by any other number, it's going to change this number. But there are many, many versions of 1. And watch what I'm going to do. If I multiply the numerator by the square root of 3, and I multiply the denominator by the square root of 3, then I've multiplied this big fraction by the square root of 3 over the square root of 3. And of course, anything divided by itself is 1. So I've ultimately just multiplied by 1. But watch why this is so powerful. When I multiply fractions, of course, I multiply straight across. The numerators multiply, the denominators multiply. The square root of 10 times the square root of 3 becomes the square root of 30. The square root of 3 times the square root of 3 becomes the square root of 9. Okay, great. We still have a radical in the denominator, but look what it is. It's a perfect square. The square root of 30, of course, is in the numerator. Nothing's changing that. But the square root of 9 becomes 3. And now we don't have any radicals in the denominator. The square root of 3 times the square root of 3 turns into 3. Now, the square root of 30, this really can't simplify anymore. There are no factors of 30 that are perfect squares. 5, 6, 3, 10, 2, 15. Anything other than 1 is not a perfect square, so this is not going to simplify. And please don't think that you can reduce these, because the 30 is underneath the radical, inside. The 3 is on the outside, so they are not in corresponding parts. And make sure that your division bar is clear. I don't want people thinking that this is the square root of 30 thirds. That's not it. It's the square root of 30 all divided by 3. This is our simplified answer. And we just did something called rationalizing. Rationalizing is basically taking a fraction and multiplying by some version of 1. Now I'm going to put my little fancy 1 here, because ultimately I just multiplied this fraction by one big 1. In this version, it was square root of 3 divided by square root of 3, because I needed to get rid of a square root of 3. In example 1a, I need to deal with this fraction. That's no good. So the first thing I might do is make this the square root of 3 divided by the square root of 5. And then I see that there's a radical in the denominator that I need to get rid of. So what I'm going to do is I'm going to multiply this time by the square root of 5 to the denominator, but also to the numerator. And let's see what happens. The numerator becomes the square root of 15, and the denominator becomes 5. Now, some people might say that this is the square root of 25, and that's fine. The square root of 25, though, of course, is 5, and we're finished. We just rationalized. No more radicals in the denominator. No more fractions as a radicand. Let's see what happens in example 1b. There's a radical in the denominator. That's breaking rule number 1. So I'm going to multiply by the radical that I see. So the square root of 10x and the numerator by the square root of 10x. I'm multiplying the numerator. I'm multiplying the denominator. Now the numerator did not have a radical, so it's just a 2 times the square root of 10x. So that's just 2 times the square root of 10x. Remember, the things on the outside stay on the outside. The things on the inside stay on the inside. The denominator becomes the square root of 10x times the square root of 10x, which cancels out sort of and becomes 10x. Again, you might say that this is the square root of 100x squared, but the square root of 100 is 10, and the square root of x squared is x. So just realize that the radicand just pops out because squaring a square root undoes each other. But now look at this. We have some stuff on the outside, and 2/10 can reduce. So I can reduce each part. The 2 will reduce to a 1, and the 10 will reduce to a 5. So I'll have 1 square root of 10x divided by 5x. Now again, remember, this is the stuff on the inside. Nothing's going to change that except other things on the inside. This is stuff on the outside. So they do not combine in any way. And our final problem, example 1c, I see we have the same dilemma. We have a square root in the denominator. Now, some people will just go ahead and multiply by the square root of 30 divided by the square root of 30. And you can do that. But I see that these numbers reduce. So what I'm going to do first is I'm going to put it together as one big fraction, because I know that 5 and 30 share a same factor. I can reduce this. This reduces to 1/6. Now I know that that does not really help me because it still is a fraction, but at least it's a tinier fraction. Well, it's the same fraction, I know, but it's smaller numbers at least. So now I can change this, or at least deal with this. The square root of 1 divided by the square root of 6, I'll deal with that. At least it's a smaller number, smaller radicand. I'm still going to rationalize by multiplying by the square root of 6 and the square root of 6. So I'm going to get my denominator simply becomes 6. And my numerator becomes square root of 1 times square root of 6, which is square root of 6. So square root of 6 divided by 6. There we go. You can check to make sure that you're correct. If you want to plug this into your calculator, watch out for your parentheses, of course. Plug this in, you'll get some random decimal. And then plug your answer in, and you'll see that you get the same exact random decimal. This is called rationalizing, and right now we're dealing only with monomials. That's single terms in the denominator. Thanks for watching this tutorial, and I'll see you in the binomial rationalizing tutorial next. See ya.